In this lecture, you will learn one of the core concepts in Linux and generally operating systems, which is operating system users and their permissions. We will see Linux commands for creating users and groups, as well as understand how permissions work and how to give users and groups in Linux different permissions to work with files and do things on the system. First of all, there are three categories of users that we may have on a Linux system. First one is the root user. This is a special type of user that has unrestricted access and permissions to the whole system, also called a super user because it can do anything. Whenever you want to do some administrative tasks or access restricted files, for example, on your system, you need to log in as a root user, or you need to execute commands as a root user. A second type of user are regular or standard users. These are the users that we create to log in to the system. So if I want to use a computer or a server, I will have some standard user that I can use to log into the system and then do stuff there. And each regular or standard user will have its own dedicated space that we already saw in /home directory in a folder that has the same name as that user. And the third type is service user. The service user is relevant on Linux server distributions because Linux is widely used for servers, and servers run different services, like a database server or a web application server, etc. And it can run multiple of those services. So you may have an Apache server application running on a server, as well as MySQL, database, etc. And each such service or application will actually get its own user. So they will not be started by a standard user or a root user, but rather they will have a dedicated, for example, MySQL user or Apache user that will start the application. Why? Because this makes sure that each application is isolated in terms of permissions from each other and ensures better security. And this is a best practice in server management and DevOps to run the services with their own dedicated user. Running a service with a root user is very bad because this will create a lot of security issues. So no service should be run with root user because then that service will get actually root user privileges. And it may accidentally disrupt the system, or if someone would hack into our system and that application specifically, they will be able to do more damage to the whole system with a root user privilege. So these are the three types of users that you will have on a system. And on one machine, you may have multiple of those users. You always have one root user, obviously, per computer or server, but you may have multiple regular users in addition and multiple service users. Now, why do we need multiple standard user accounts, for example, on one machine? Let's say we have a personal laptop or computer that you use at work or university. Why would you need multiple accounts? Well, the main reason is to be able to share your computer. For example, many companies use Windows operating system for personal computers or laptops that the employees would use. And each personal computer or laptop can actually be accessed by any of the employees. So if you change your hardware, if you change your laptop in the company, you will still be able to access that laptop. You will be able to log in with your user. Same thing at universities. Many universities have computer labs that can be accessed with computers, and each computer can be accessed by any student in the university with their own personal login credentials. So how does this work? Does every computer have a copy of all the accounts? Well, for Windows, and that is actually a difference between Windows and Linux, Windows has a possibility to centrally manage the users. So the administrators at workspace or the university, they will usually configure a system with a list of all the students or all the employees with the user accounts for each one of them. And then all the computers will be connected to the system. So whenever someone tries to log in to a computer at work, for example, then the operating system will ask that centrally managed system, hey, there is this user that is trying to log in. Please check the credentials and give an access if the credentials are correct, or if you have that kind of user. So when you log in to such computer, you will see your home folder and that's it. You don't have access to restricted folders or system folders, and you will have no access to other users' folders, so everything is nicely isolated. And depending on permissions, if the permissions are strict, you may not be able to change anything outside your home directory. For example, you will not be able to just install software on your computer because, as we saw, these installation files end up outside your home directory. So in Windows systems, the centrally managed user permissions allows you as an employee, for example, to log into any hardware, any computer that is connected to the system at work and basically see your home directory with all the files and everything that you have there and continue working from there, so you're not tied to the hardware. But as I said, this is specific to Windows, and Linux actually doesn't have that capability. That's one of the reasons why in many big companies or universities, Windows is used as an operating system. However, on Linux machines, you still have a possibility to register multiple users. However, these users will be managed on that specific hardware, that specific computer. If you log in on another computer, you're going to have users that are registered on that specific computer. So it's different from one computer to another. And again, this is a use case if you want to share the same computer with many users, for example. In Linux, however, this multiple user accounts is more relevant when we're talking about servers, because usually servers are managed by teams of administrators or engineers, so multiple people need access to the same servers. Now, you may be asking, why can't all the team members just have one account or one user and then basically access the server with that user? So have a shared user basically, instead of having their personal files. Because it's a server, so they're just going to be managing some services there anyways. Well, let's an example of why giving each team member their own user is actually important. Let's say we have 2 servers in the company maintained by a system administrator's team of 3 people. First of all, you don't want to give them all root password, right? So they need to have a non-root user. Because again, root user should be just used by the system, and whenever you need to access a restricted file or do something that needs a super user privilege. But other than that, you should be always working with a non-root user. Also, you can decide per team member what permissions they get, because someone may be a senior administrator, another person may be a junior, so they may actually get less privileges and less permissions to change stuff on the system or to access certain locations. Also, with multiple people working on the server, you want to track who did what on the system. So you want the traceability on the system, because if it's an important server, like a production server, for example, and you want to know what happened by which user at a specific time, not for blaming, but just knowing who can help resolve that issue. So these are the reasons why you would want to give each team member their own user accounts to work on servers. So when you get a fresh new server, an admin will usually create those users so that the team members have access to it. And in the next section, we're going to see how creating users and giving them permissions actually works. Now, how do we manage permissions for users on Linux systems? We can manage permissions on 2 different levels. The first one is we can give permissions to users directly. So we can say, a new user, Nana, will have a permission to install applications on the system. She will have a permission to execute commands with super user privilege, etc. So we can do that per user. Another way of managing user permissions is by grouping users into Linux groups and then giving that group certain permissions. And this is actually the best way of doing it, especially if you're managing multiple users, by defining a group on a Linux system. For example, if you have a DevOps team, then you would have DevOps group, or you may have an admin group. You may also have a group for developers, and then you would add all those users to the group, and then you would have permissions defined for that group and not directly for the user. And this is actually super convenient and way easier to manage if you have tens or hundreds of users. Let's say if you have 50 users, you don't want to set permission for each one of them one by one, and then when they're not in the team anymore, then take permissions from them and so on. Way easier is to just add the user to the group, so we'll get all the permissions that the group has, and then remove the user from the group, and it will lose all the permissions that it had from the group. And that's why usually when we're working with users, we also work with groups. So each user will be part of a group by default, and then you can add a user to multiple groups even. So they will get all the permissions from all the groups that they are part of. And this is actually a very important concept in Linux systems. So now that we know all this theoretically, let's actually see how managing users and groups on Linux actually works in practice. So back on our Ubuntu system, where we're going to see how to create new users and how to give them permissions. First of all, let's see where all the users that the system has is actually stored and how we can access that list. That information is actually stored in /etc/password file. And since it's a file, we can just print the contents of the file. Again, if you remember, /etc is the system configuration location. And that's where we have the users that are registered on the system. So if I print the contents, you see this not very user-friendly list. However, it's not very complex actually. Each line here represents a user, like this one right here, which is my user that I created. And let's see what all this information actually means. First of all, we have the name of the user, then we have X, and you see that there is X for all the other users, and this is actually a placeholder for the user's password. Obviously, it's not displayed here in plain text because it's a password, it's a sensitive data, so we just see a placeholder X. The password itself is actually stored in another file for security. Then we have a number here that actually represents the unique ID of the user. So my user, Nana, has ID of 1000, and root user on the system always has an ID of 0. The second number that we see here is the primary group ID for that user. So groups also have their IDs, and each user will have a primary group which that user is part of, and that primary group ID will be stored here as well. Then we have the user description and full name, etc. This is the user's home directory, and this is user's default shell. /bin/bash, which is actually the shell that we're using here to execute different commands. And as I said, this is a file. So how do we add a new user? It's actually pretty easy. We already saw that command, add user and username. And let's call this one Tom. However, adding a user in a system is administrative task, so we are gonna need super user privilege here. And if I execute and enter my password, this will create a new user, and we have to set the initial password for the user. add the full name, room name, whatever. And confirm. And again, if we now print out the list of users, we should see Tom right here. And this information that we entered, they're all listed here, comma separated. And Tom also got its own user ID. And this is the primary group ID of the user. Now, where does this primary group actually come from? Well, whenever we create a user using user add, by default, it also creates a group with the same name as the user and sets that as the primary group ID of the user. So this is the group called Tom and its ID here. And that's the default behavior. You can also change the password of a user using password command and username. And of course, this is also an administrative task. And now we can set a new password. And there you go. Password updated. Now we could actually log out from the virtual machine and log in as Tom user, or we could do that directly on the command line as well, using command su dash and username that we want to log in as, and their password. And right here, as you see, we're logged in as Tom user. This is just a name of the computer, but we are in Tom's home directory right now. And the same way, we can switch back to my user like this. Using the same command, you can actually log in to the system as a root user. So without specifying any username here, by default, this will be root. So su dash will log you in as a root user. Of course, you will have to specify the password of the root user. Now let's say we want to create a new group called DevOps, where all our team members or engineers will be added, and then we can add the permission to that DevOps group instead of adding permission individually to each user. So how can we add a group? Also super easy, sudo group add and the group name. And we're gonna add a new group called DevOps. And of course, if we want to verify that the group was added, we can print the list of groups from /etc/group file. And there you go. At the end, we have the name of the group and the ID of the group. A small note here on the commands for creating users and groups. If you noticed, I used a command add user to create a user and group add to create a group. So basically, in most Linux distributions, we have the following command pairs when creating users or groups. We have add user and user add group and group add. And if you see examples with these commands on internet, it may get confusing. So what is the difference here? On most distributions, add user and add group are interactive, more user-friendly options of the commands user add and group add. What does interactive and user-friendly mean in this case? It's easier to use and all the info you need to create a user or a group, like ID or home directory, etc., gets set automatically. Or it asks you for an input in interactive mode, like with password. Whereas for user add and group add, you need to provide all the needed information as parameters, since these are more low-level commands. So which one should you use? As a rule of thumb, use user add, group add commands in scripts when you're executing these commands in an automated way, and use add user and add group commands when executing them manually. The same goes for user del or delete and del user, as well as group del and del group command pairs. Now let's say we want to change the primary group of user Tom to DevOps. How do we do that? Using a command called user mod, which modifies or changes the user. So we can do user mod minus or dash G, the primary group that we want the user to be in, and the username. And if I execute this, this will make DevOps the primary group of user Tom. And now, since we don't need the Tom group anymore, we can remove it using del group or group del command. So we can do del group Tom, and this will remove the group called Tom. Now, we can add a user to multiple groups, right? So in addition to one primary group, a user can have multiple secondary groups. And as a result, user will get all the permissions that the groups have which it belongs to. To add a user to multiple secondary groups, we can use user mod dash capital G, and then list of the groups that we want the user to be added to. So we can do admin and some other group here and username. In our case, let's just add Tom to admin group, but know that capital G option will overwrite the whole secondary groups list. So it always sets the new list of groups for the user. If you want to add user to a new secondary group in addition to the existing ones it already belongs to, we use an option A in addition. So using this command, we can basically append a new group to the existing groups. So as you see, Linux commands accept different options to change their default behavior, which is an example with the user mod command. But for other commands as well, like add user, add group, etc., you can use different options to set a custom ID and change the defaults for the user or group when creating them by adding options to the command. You can check the documentation or what's called main pages or manual pages for any Linux command to see all the options you can use with it. Great, so now that we have added user to multiple groups, how do we actually print out or see all the groups a user belongs to in an easy way? Well, there is a command for that too, called groups, which displays the groups the currently logged in user belongs to. But with groups username, like groups Tom, for example, we can display the groups of any other user. We can also log in as Tom user to Tom's account and display the groups there as well. And if we switch to user Tom and groups, right here you see that Tom is in DevOps and admin groups. And if we want to move back to the previous user, we can also do exit. So this will log out the user and I'm back in my previous user's session. We can also add users by specifying the group at the creation time instead of going through all these steps. So when adding a user add command with a name like Nicole, for example, we can actually specify the group right here. Let's say this is the DevOps group. So this will add Nicole user to DevOps group. However, it will still create the default group with the same name. So if we check now the users list, we have a new user here with a primary group ID of this group. However, it's also added to the DevOps group. Now, if you want to remove a user from a group, for that you would execute a command called g password, and then you have a flag for delete user and the group. So this will remove the user from the specified group. I'm going to execute, and we have removing user Nicole from group DevOps. And there you go. So this is how you work with users and groups in Linux. In the next part, we're going to see permissions for users and groups.